Hello and welcome to another lecture, and today we're going to do a review, and we're going to start mentioning these acoustic variables that we have 3 of them. Do you remember? So we have number 1, we have the pressure, and number 2 we have intensity. And then number 3, we have distance. And we have another name for distance. We call this particle motion. Okay, those are the acoustic variables. Remember, they need to have this rhythmic oscillation in order to be acoustic variables. They change all the time in the areas of compressions and rarefactions. So what is pressure? Pressure is how much force you apply in one area, right? How much force you're applying in one area. And that's why we use the units of Newton per centimeter squared. Density is how much mass we're able to concentrate in a volume, and that's why we use the units of grams per cubic centimeters. And distance is basically distance. How far is something from a point? And for distance, we're going to use millimeters, centimeters, right? So distance, remember, is the same of particle motion. But then remember, we have these acoustic parameters as well. We have 7 acoustic parameters of this wave that is continuous, because later we're going to study acoustic parameters for the pulsed wave. But that's something that we're going to see later. So for now, let's mention those acoustic parameters, and we studied those in the following order, if you remember. All right? So number 1, we got the period. Number 2, we have the frequency. Then 3, 4, and 5, we have the 3 bigness parameters. Those are amplitude, right? We have intensity, and then we have power. And then number 6 and 7, they go together as well. We have propagation speed, and then we have the wavelength. So now pay attention and take notes. What we're going to do right now is just like discuss this one more time, saying which one is adjustable or not, and which one depends on the sound source, on the medium, or in both at the same time. So we're going to begin with the period. Remember, period is the time for the cycle. Time for a cycle. And we use microseconds. And remember, this period is non-operator adjustable, right? Non-operator adjustable. And it depends on the sound source, right? Perfect. What about the frequency? So frequency is how many cycles you have in 1 second. We use units of megahertz, and it is inversely related to the period. If frequency goes up, period goes down. If you're not using a multi-frequency probe, then frequency is non-operator adjustable. And it also depends on what? Depends on the sound source or machine. Remember, sound source or machine is just the same thing, or system is the same thing. So then we have the 3 acoustic parameters: amplitude, intensity, and power. If you remember, amplitude is the height of the wave. We have a positive amplitude, we have a negative one, we have a peak-to-peak amplitude. And this is the only acoustic parameter that behaves like a variable, because it goes up and down, up and down, up and down. It alternates that way. So amplitude uses units of decibels, right? Remember from previous lectures. And it is adjustable. It is adjustable using one setting that we call the output power, and it depends initially in the sound source. And I think we're gonna do like star sign in here, so you remember that the word is initially, because later the sound is gonna suffer something, just gonna go through something that we call attenuation. So the sound becomes weaker as it's going through the tissues. So then we have intensity. Intensity is basically how much power you're able to concentrate in one area. Remember, I told you in previous lectures that the highest intensity area of the sound beam is going to be the focal point, because that's where you have the smallest area and where all the power is going to be concentrated. So intensity is how much power you're able to concentrate in an area. It uses units of milliwatts per centimeter squared, right? And it is also adjustable using the output power as well, and depends initially on the sound source. All right, look at this one more time. Remember something. Intensity is directly related to the power. Intensity is directly related to the amplitude squared, and power is directly related to amplitude squared too. Meaning that if power goes 2 times up, for example, intensity is going to go 2 times up. But if amplitude goes 2 times up, then intensity is just going to go up exponentially. All right, think about this. If amplitude goes 2 times up, intensity is going to go 2 times 2, 4 times up. If amplitude goes 2 times up, also power is going to go up 4 times. So the growth is going to be exponential. So remember, we talked about this different type of intensities in order to report bioeffects. And the one that we paid attention was the SPTA, because we have this limit for, this intensities that says the following: there are not confirmed harmful bioeffects over intensities that are 100 milliwatts per centimeter squared SPTA if the sound beam is focused, and if it is unfocused, all right, and if it is focused, then we're gonna get that number is gonna be 1,000 milliwatts per centimeter squared SPTA. Let me repeat this one more time so you don't get confused. Let me repeat myself one more time. If the sound beam is unfocused, then that number is going to be 100 milliwatt per centimeter squared SPTA. All right? If that sound beam is focused, then that number is going to be 1,000 milliwatts per centimeter squared SPTA. Now I think it's like clear to understand this. And always take notes, okay? Always take notes. I try to keep it like sharp all the time, but remember, I'm a human being, all right? So, but thank you for understanding that, and take notes, all right? Perfect. So, that's for intensity. If you guys remember, power as the work performed by the sound wave, and power, we use units of watts, and it of course is going to be adjustable as well using the output power. We're talking about the acoustic power in here. And when I say the output power, is how much electricity you're able to, or the system is able to apply to the crystals, right? If there's more electricity going in, of course the sound wave is going to be more powerful. And it depends initially on the sound source as well, all right? Then later, this 3 bigness parameters, 3, 4, and 5, amplitude, intensity, and power, they will become weaker. The sound wave is going to become weaker as it's just going through the tissues, all right? Because the attenuation is something that we're going to see next in our, interaction of the sound with the medium. So then we have the number 6, which is the propagation speed, how fast the ultrasound goes through the tissues, all right? And this is, remember, a property of the medium. So therefore, non-adjustable, and it depends on the medium, all right? Don't forget about this. So propagation speed depends on the stiffness and density of the tissues. If there is more stiffness, then the sound is just going to travel faster, so there will be more propagation speed. If there's less density, there will be more propagation speed. So you're going to have the highest propagation speed value when there's more stiffness and less density, more stiffness and less density. But please don't forget about this. If we have more elasticity, which is the ability of a tissue to deform, more elasticity, then we're going to have less stiffness. And less stiffness is going to give you less propagation speed. So in other words, elasticity and propagation speed, they are inversely related. So don't forget about this. So for propagation speed, we use meters per second. And don't forget about this number that we call propagation speed in soft tissue, which is 1540 meters per second. It is also expressed as 1.54 millimeters per microsecond and 1.54 kilometers per second. Everything is just the same thing. This is a real virtual number that your system uses in order to calculate something that we call depth of view, and that's something that we're going to discuss when we talk about the range equation. So how is it going so far? I think this is a nice review for you to understand all these acoustic parameters in a glance. So moving forward, we have the wavelength, which is basically the distance from one peak of one cycle to the next peak of the next cycle. So wavelength, if you guys remember, wavelength is inversely related to the frequency. So this way we have wavelength equals propagation speed over frequency, all right? The frequency goes up, wavelength is going to go down. We use units of millimeters, all right? And remember this, propagation speed is the property of the medium, all right? It's the property of the medium. Frequency depends on the system. So wavelength is going to depend on both, and of course is non-adjustable and depends on both, and is non-adjustable because the frequency, if you don't have a multi-frequency probe, you're not able to adjust it, or and if you remember, the propagation speed is not, you cannot change it because that's a property of the medium. It depends on the stiffness and in the density of the tissues. All right, so please take a look to this one more time. If you take a look to all of this, the only three acoustic parameters that are adjustables are these ones right here, the three bigness parameters, all right, 3, 4, and 5. All right, so cool, right? So period, frequency, propagation speed, and wavelength, they are non-adjustable, non-operator adjustable. If you take a look to this, everyone depends on the sound source or medium, right? Right here, except for the propagation speed that depends only in the medium, and the wavelength that depends in both, right? Does it make sense? I think we have all this information at a glance in here, so and then at a glance in here, and then you're going to be able to remember all this information, because believe it or not, we're going to keep using this in next lectures, and we're going to keep talking about, you know, all these nice principles. All right, with this part, we're done with the introduction and basic principles for ultrasound. So I'll see you next time for interaction of sound with the medium, and then we're going to keep having fun. Thank you for making it today, and I hope you're taking notes and understanding all of this. Thank you, and I'll see you next time.